Ever stop to think about that unsung hero of your inbox? The spam filter. It's working for you all day, every day. But how does it actually know it's junk? Well, today, we're going to pull back the curtain and look at this surprisingly simple math that makes it all possible.
Seriously, think about it. How does your email app just know that an email about a once-in-a-lifetime opportunity is total junk, but that message from your boss is super important? It almost feels like magic, right? Well, it's not magic. It's math, and it's way more intuitive than you probably think. So, the secret weapon in this fight against spam is basically an automated detective. It's a machine learning technique that's really good at one thing, sorting stuff. And it's got a name, the naive Bayes classifier. So what is this thing really? Well, at its heart, the naive Bayes classifier just uses probability to put things into different buckets. In our case, it's two main buckets, spam and not spam, which people in the field often call ham. But here's the thing. It doesn't start out smart. It has to learn, and it does that by studying thousands upon thousands of emails that we've already marked as spam or not spam.
Okay, but let's talk about that name for a second. Why on earth would you call a clever piece of tech naive? It sounds kind of dumb, right? Well, it turns out that naive part is actually its superpower.
So, here's the big secret. The classifier is naive because it makes one giant, simplifying assumption. It assumes that the order of words in an email means absolutely nothing. To this algorithm, an email isn't a collection of sentences with grammar and structure. Nope. It's just a big, messy bag of words.
To see what I mean, look at these two headlines. Dog bit man and man bit dog. To you and me, those mean wildly different things. But to our naive Bayes classifier, they're exactly the same. It just sees a bag with three words in it, man, bit, and dog. Now, we know this is technically wrong, but it's a brilliant shortcut. It's what makes this whole process so incredibly fast and efficient.
Okay, so it sees an email as a jumble of words in a bag. That's kind of weird, but how does it get from that jumble to a final verdict? How does it actually crunch the numbers and come up with a spam score?
The process is actually pretty simple. Let's stick with our detective analogy. We start with a completely neutral view. There's a 50-50 chance this email is spam. Then we look at the evidence, one word at a time. Each word has a pre-calculated spamness score. All we do is take our current odds and multiply them by the score for that word, updating our level of suspicion as we go.
Let's make this concrete. Imagine an email comes in with just two words, million conferences. Our classifier has already done its homework. It's looked at tons of emails and knows exactly how often these words show up in spam versus regular email, or ham. These numbers right here, these frequencies, that's our evidence.
So before we even look at a single word, what are the odds? Totally neutral. 1-to-1. It's a coin flip. Could be spam, could be ham. We have no idea yet.
And then we see our first piece of evidence, the word million. Looking at our data, we see that this word appears about 5 times more often in spam than in ham. So we update our odds. We take that starting 1-to-1 and multiply by about 5. And just like that, the odds are now over 5-to-1 in favor of this being spam. Our detective is getting suspicious. But hold on, what about the next word, conferences? Well, this one completely flips the script. It's way more common in legit emails. Its spamness score is actually less than 1. So when we multiply our current odds, that 5-to-1, by this new, smaller number, our suspicion just plummets. We're all the way back down to 1.3-to-1. Maybe it's not spam after all.
You can see how every word shifts the odds, right? It pushes our belief one way or the other. So, to really lock this idea in, let's use the exact same logic on a totally different problem. Let's try the loaded dice challenge.
All right, here's the setup. You've got a die. Could be a normal fair die, or it could be loaded to favor a certain number. You start rolling, and you get a 6. Then you get another 6, and another. The question is, how many 6s in a row would it take for you to be practically certain, let's say 100-to-1 odds certain, that the die is loaded?
First things first. Just like with our spam filter, we need our base probabilities. We know a normal die will land on a 6 about 1/6 of the time. But this particular loaded die we're worried about, it's rigged to land on a 6 a full 50% of the time.
Now, let's calculate our evidence score. It's simple. We just divide the loaded probability by the normal one. So 50% divided by about 17% gives us a ratio of 3. That is our magic number. It means that every single time we roll a 6, the odds that this die is loaded triple.
Okay, let's do this. We start at 1-to-1 odds, totally unsure. Then, bam, our first roll is a 6. We multiply our odds by our magic number, 3. We are now at 3-to-1 odds that this is a loaded die. Not certain, but definitely suspicious.
Let's keep going. We roll again. Another 6. The odds triple again, up to 9-to-1. And a third 6 in a row? We triple them one more time. Now we're at 27-to-1. You can feel how quickly the evidence is piling up against this die being fair.
So, how many rolls does it take to cross our 100-to-1 finish line? Well, the fourth roll gets us to 81-to-1, so close. And that fifth consecutive 6 sends the odds flying past our goal to 243-to-1. At this point, yeah, the case is closed. You're holding a loaded die.
You see, whether we're talking about words in an email or the rolls of a die, the principle is exactly the same. It's not about one single piece of evidence being a smoking gun. It's about the incredible power of accumulating lots of little pieces of evidence, one by one, to steadily update a belief. That's the simple, beautiful engine of probability at work.
So, let's bring it all home. What's the big takeaway here? First, that this powerful tool, the naive Bayes classifier, is really just using simple probability to make sense of our world. Second, its real trick is updating its beliefs with every new clue it gets. And finally, its so-called naive assumption, ignoring word order, is actually a brilliant move that makes it super fast and surprisingly effective. It's a cornerstone of machine learning for a very good reason.
So I'll leave you with this question to chew on. Now that you understand this simple detective and its method of updating beliefs with evidence, where else could you use it? What other hidden patterns out there, maybe in medicine or finance, or even just in your everyday life, are just waiting to be discovered by this simple, powerful idea of tracking the odds?